The real power of the SF package is the ability to easily create plots of spatial data. So first we're actually going to talk about how to plot geometry list columns, or SFC objects. So if you want to simply plot the geometry list column of an SF object, then you can use the st_geometry function to extract the list column of simple feature geometries from the SF object, and that's going to have class SFC, and then use the generic plot function to plot the associated SFC object. So if I take my US_SF object and I use the st_geometry function to extract the geometry list column, I then use the plot function to plot the associated geometry list column. And you can see that I have a map of all of the US states, including Alaska, Hawaii, Puerto Rico is over here. And this actually, what's over here is actually a continuation of Alaska. And so some of you may not have known that Alaska is actually the westernmost US state and the easternmost US state, because it actually crosses the international date line. So that's certainly not true of the contiguous US, but if you're looking at the entire United States, then it's the farthest west and the farthest east. And this is covering a lot of area, and so we'll see shortly how we can focus the plot on a smaller region if we want. So alternatively, instead of using the st_geometry function to extract that geometry list column, you could have actually just used the $ operator and selected that directly. In our US_SF object, the geometry list column is actually called geometry. So we can extract the geometry list column, and then we plot that, and we get the identical plot to before. As I mentioned, you might want to customize a graphic, and this is essentially working, this generic plot function here is essentially base graphics. And so we can modify our plot in a very similar way to similar to how you would modify base graphics. So I am going to add the axes. So I think it's actually helpful to know exactly where we are in terms of longitude and latitude. So if we set axes equal to true, that will display the axes. You can change the X labels, the axis labels using XLab and YLab like you would regular base graphics. If you want to change the plotting window, then you can specify XLim and YLim. So I do want to point out, when you plot the axes, so usually what I do is I actually plot the axes first, I figure out what the coordinates are, and then I use that to adjust the XLim and YLim to a better viewing region. But it's a little weird here because you have 130 degrees west, 120 degrees west, and so on. And so you might think to yourself, well, how can I add a number and characters for XLim and YLim? And the answer is you don't have to. So this is notation or syntax that people use to describe these coordinates. But essentially the W values here, these are considered negative numbers. So this is essentially equal to negative 130, negative 120, out to negative 70. And so I can constrain the plotting region like that if I want. And if I have N here, these are northern hemisphere latitudes, then these are going to be positive values. So these are essentially 25 up to 50. And if I had S here, if I had southern hemisphere latitudes, those would be negative numbers. And if I had eastern hemisphere longitudes, then I would actually use positive numbers. So in order to constrain the graphic above to a narrower viewing region, I'm going to constrain the x-axis from negative 125 to negative 75. So it's approximately right here to actually here. So I didn't set a very good plotting region here, but it turned out okay. And the Y limit, I went from 22 up to 50. And so this gives us a much nicer plotting region. Notice also that I can change the fill color of my geometry objects by specifying the COL argument here. The border argument I specify to equal blue, and so I get blue borders. There's nothing particularly nice about this graphic, but it just shows you some of the customizations you could do. You could add a title if you wanted using the main argument and so on. I did want to also point out that you can get really creative if you want in order to make your plots fancier. And so essentially what I've done here is I wanted to color all the C states, so California, Colorado, and Connecticut, a little differently than the other states. And so what I did here is I have some code where I take the STUSPS column of the US_SF object. I find which entries in that vector start with the letter capital C. And so I'm going to call those C underscore states. And then I'm going to create a vector myCall, which replicates the value gray here, the gray character string, as many times as there are rows in US underscore SF. So essentially this is like, initially I want to set myCall equal to gray for every single observation in the US underscore SF object. And then I'm going to take C underscore states, which only has true values for the states that start with a C, and I'm going to change those entries of my COL, my call, to orange. So just 3 of the values go from gray to orange, and I'm going to do something similar with a my border vector. So I'm going to replicate the character string yellow as many times as there are rows in US underscore SF, and then I'm going to change the values for the C states of my border to blue. And so now when I plot my geometry list column for US underscore SF, I can set COL equal to my call, border equal to my border, and now it's going to individually color the states according to the values in those 2 vectors. And so most of the states are going to have a gray fill, but the 3 C states are going to have an orange fill, because that's what I specified up here. Similarly, the border of most of the states is going to be yellow, but then for the C states, I set the border equal to blue. And this doesn't look as good as it could because it depends on the order of when these are plotted. Some of these lines, some of these borders get over plotted by some of the other states and so on. But you can see that we did a little bit of customization for how we wanted to color the different states. And this could be very important if you were doing spatial data analysis and there was some aspect of these states that was different than the rest. You might want to color them a little differently. So I've just given you an idea of the kind of procedure or the kind of process that you can use to distinguish certain polygons or certain geometry objects from other geometry objects in your geometry list column.